the quote for this chapter, I took German in college, but I'm not going to try that. The energy of the world is constant. The entropy of the world tends towards a maximum. And that is a statement by Rudolf Clausius, who is the Clausius of the Clausius-Clapeyron equation. So this chapter is about free energy and thermodynamics. And we will learn that free energy does not mean what you think it means. So, nature's heat tax. You can't win. The first law of thermodynamics is that energy is conserved in chemical processes. Sometimes this is expressed as you can't win, other times as there is no such thing as free lunch. There is no free lunch. The idea here is that you cannot create energy that wasn't there to start with. The energy of the universe is constant, and you cannot just make energy out of nothing. So, burning gasoline to run a car. Only about 20% of the energy released by the combustion of the gasoline actually goes towards moving the car. The rest is dissipated as heat. So, it's not that energy is lost, but it's lost to being useful. Are we doing that again? So the energy from the reaction equals the energy moving the car plus the heat that gets lost. So you can't win, and even more depressing, you can't even break even. So this is related to the second law of thermodynamics, which we'll talk about soon. And this has some direct applications towards, the idea of green energy and, what's actually helping the planet and what isn't. So, rechargeable batteries are great, right? But if the battery does 100 kilojoules of work, it's going to take more than 100 kilojoules of energy to recharge it. Okay? So, the energy isn't lost, it's not destroyed, but it's lost to the surroundings, generally as heat. Anytime there's a transfer of energy from one form to another, some is lost to usefulness. And so we call that the heat tax. Like every time you buy something, the government takes a piece of it, right? So nature imposes a heat tax. Additional energy is lost because real-world processes are less than 100% efficient. So the fewer transactions that you make, the more efficient the energy use is. But the bottom line is you can't break even. So here's looking at heating with natural gas versus heating with electricity. So when we burn natural gas, we get heat and we lose some to the heat tax. When we burn fossil fuel to make steam, there's a heat tax. When the steam is used to make electricity, there's heat tax. When the electricity is transmitted, there's heat tax. When the electricity goes to run your electric heater, there's heat tax. And the heater heating your thing, there's heat tax, right? So what's more efficient? What's better for the environment? For this purpose, natural gas, right? So, if you're like trying to decide, should I install a gas stove or an electric stove? A gas dryer or an electric dryer? Well, the purpose of those things is to generate heat, right? So, burning natural gas, you're going to lose less to the heat tax than going through this long process with electricity.